right, welcome everyone to this wonderful lightning talks where we have some of the top 4 projects giving their an overview of their project, a short presentation, a so-called lightning talk. And of course, this is for the AI and Democracy Hackathon, where we spent a weekend trying to demonstrate and find solutions to major risks to democracy from AI. And we had 150 signups with 25 entries, so it's really awesome. And of course, all these entries are live on the website, and a lot of just really great work there. So I don't know if you say really proud of you all, but it's really awesome. It's great work, and we were excited to look through it as judges. There will be judge feedback on those pages as well as we get into the next few days. That has all happened in private until now, but those will get on there as well. And of course, today we have a few projects to showcase. We have Jekyll and HAIde, and unfortunately, I think their team could not join us for this session. But we have Artificial Advocates, we have Beyond Refusal, and Unleashing Sleeper Agents. And afterwards, I will present who the winners are, and the winners will, of course, get an immensely cool certificate that we've already set up for you, along with a prize. So that is very exciting. Look forward to that. It's really impressive diversity you see over here on the right, all the 25 projects submitted. And the first team to present will indeed be Artificial Advocates.
Great, thanks Esben, and thanks to HAIde for setting this up. It's been a lot of fun. Appreciate it. All right, so our project is called Artificial Advocates, Biasing Democratic Feedback Using AI. We have a great team from around the world. The brief is, here's the threat. Democracies need public feedback systems, and AI may threaten those systems. So we looked at 2 possible attacks on an existing system that gets feedback from the public. One attack is quantity, second is impersonation. So the quantity attack is the theory that you could use an AI system to flood these public feedback mechanisms with plausibly human comment. The second attack is the idea that we could use LLMs to impersonate organizations that have a little more credibility in this process, and again, create a bunch of comments that would be difficult to validate. We're also going to discuss what the expected future capabilities of these models might be in terms of this attack, and then talk about how it could be mitigated. Are there existing approaches that could be used that could help to prevent this sort of thing? So the initial goal is to find a vulnerable system and then build tools to attack it. I used to work in Washington, D.C. as a technology policy analyst. I'm familiar with the Federal Register. So for those who are not familiar, in the US, you have the legislative process with laws, and then you have the regulatory process with rules. And federal agencies are required to publish proposed rules in a document called the Federal Register and allow the public to comment on those proposed rules. Commenting is very easy to do, very low barriers. There's pros to that, right? Everyone can be a part of the process, but downsides are it makes it pretty easy to attack. So this system in particular may be at risk in 2 ways. One is crowding out of these human comments. So some of these comments, or some of these rules get thousands of comments. They can have a lot of people give their feedback, but it's very easy to make thousands of comments with AI. So you can potentially crowd them out. And they have these tools in place now to prevent these sort of bot attacks. But these bot attacks usually are like form letters, things that are pretty easy to spot. But if you make them more personalized, make them sound more human, then these aggregate tools can be skewed in favor of the attacker. The other way is by impersonating large organizations. Organizations have a little more weight. They have higher quality comments, but we can try to make comments that look like they're from these organizations as well. So we had 2 hypotheses. One, the current LLMs are capable of creating comments that are indistinguishable from human comments, both in their perceived realness, humanness, and in persuasiveness. And the second is that they can impersonate large organizations to exploit this lack of identity verification used by the agencies. So our methodology was to use a survey to determine how real and persuasive the LLM comments can be. To do this, we had to have human comments. And to do that, we took a proposed rule that's open right now for comment, is about student loan forgiveness. We took down 1,821 comments, and then we selected randomly from those. We omitted anonymous comments and ones that were too long because we didn't want to force our survey people to read a lot. And then for the AI-generated comments, we used a Google Colab to coordinate our code. We used Llama 3 7dB instruct model using the replicate service. We had a library called Faker where we pulled in a fake name and location, created a backstory, and then generated the comments, something Jeremy's going to talk about in just a moment. And we had hundreds of comments generated during this process for less than $1, right? Very, very cheap. All right, I'm going to hand it over now to Jeremy to talk about the prompting.
Hey, everyone. Yeah, so when our initial attempt at generating these comments ran into an issue of the LLMs continually spitting out, you would ask them for, make up a person, make up a comment in opposition or support of this policy, and they would kind of spit out the same thing. It would always be Ava Morales from Fresno, California, in 25% of the comments, right? So our way to make them a little bit more personal and diverse and harder to filter was to do a first pass through an LLM to invent a fake persona. So this is the prompt that we used to do that. We used the Faker library just for a name and location. I rolled the dice to get a fake age and said, hey, you create a backstory for a minor character in a novel with this name, age, and location, and it would spit out a paragraph. This Ashley has 3 siblings. She's married, but her husband passed away suddenly in his early 40s. They have 2 teenage children. She's 55 now. And then we would feed this into the next prompt. So this is the prompt to actually generate the comment. So we took that paragraph biography, threw that into this prompt, and said, you're writing a public comment on behalf of Ashley. Here's her backstory. Only mention information from the background if it's directly pertinent to the comment. Comment should be, and then we had a variety of tones, a variety of lengths that it randomly chose just to further diversify things. The type of summary of the policy that we gave it was a little bit randomized. And we were using 3-shot prompting, pulling in 3 random comments from the human data set. And so this is an example of the output based on that last biography. And you can see it includes elements, personalized elements that at least aren't so easy necessarily to get out of LLMs always, and can have a huge range of diversity. So as a single parent who worked tirelessly to raise 2 children, she mentions the town she's from, and these sorts of things. People had all sorts of hobbies and particular parts of their life story that made it into the comments that were eventually potentially submitted to the Federal Register. And so then we ran these through a survey to compare them for realness and persuasiveness. Matthias is going to talk about that. Matthias?
Hey, thanks. So yeah, we conducted a survey experiment and had like a control group who only saw the human written comments and a treatment group which saw both the AI and the human written comments. And after each comment, people had to rank them on a Likert scale. First, whether they're human, and second, how persuasive they are. And at the end, they had to decide whether they would lean towards or against the policy results. So those results should be taken with a lot of caution because it's a very small sample. We only have like 38 people because obviously hackathon, it takes time to get enough participants. But like there is an indication, if you look at the left 2 bars, you see the midpoint of the scale is 4 between AI and human. So on average, people are fairly uncertain whether a comment is AI or human. But on average, they're still able to differentiate. The difference is statistically significant. If you look at persuasiveness, the difference is not significant, but like there's like some, I'm like, if anything, one could guess that AI might be a little bit more persuasive. The next slide. So looking at the experimental results, what you see are box plots with the median, the thick line in the middle between treatment and a control group. Treatment sees only human, the control group only sees human comments, and treatment group sees human and AI comments. And what you see is that the median is lower in the group for who sees human and AI comments. And this is the data of persuasiveness for human written comments. So what that means is like the same human written comments is evaluated less persuasive when there's a lot of AI written comments around them. Again, small sample size, not significant, so just take it as like a guess. But like at least there's a potential that there's a crowding out effect. Obviously, we didn't take the time constant, so it could also just be that people got tired at the end of the experiment. And we pass on to something more sophisticated with Sam.
So the last thing we did was try to build a threat model of what would an actor that wanted to influence the comments coming from industry do. There's been some research to showing that large industry players who have very sophisticated comments, often multi-page PDFs on the Federal Register, they are more likely to influence the final policy, particularly on things relevant to industry, which is very relevant for regulatory capture, as AI companies are going to be starting to lobby a lot. So what I built was a small tool that will let you put in a document number from the Federal Registry. It will generate a summary, and you can put in any company you like. It will put in a logo and generate a convincing 2-page PDF that will mimic more or less what industry has done on successful other lobbying attempts. I wanted to give a demo, but my Discord is updating, so I'll won't be able to do it this time. But we'll post a link in the chat, and we can you can play around with it. It takes about 20 seconds, and then you've got a high quality PDF that, at least at first glance, looks very legitimate, and the arguments are pretty solid as well. So I think the barrier now for anyone to submit what appears to be very convincing arguments, well formatted, is very low. So that's going to be something that the policymakers will need to take into account in the future.
Nice.
Yeah, this slide definitely doesn't do the tool justice. So go ahead and take a look at the GitHub.
So we'll just take a couple of questions. You're very welcome to just unmute now and share any questions.
Does the straighter haven exist?
Does a
What was that
straighter
question? I
haven?
didn't hear that.
Is like that's not a very deep question, but I was just wondering, like the fake data that you generated, how plausible that is.
The fake comments?
No, the fake data that seeded the backstory creation.
Oh,
So the data that
yeah,
you get from Faker.
Yeah, Jeremy can talk about like the background, but the Faker library did a good job of just pulling in random names and locations. That's all it did.
Yeah, so the Faker library was just used for a name and city and state, and those were fed into Llama 3 to generate the paragraph backstory with that prompt that we showed. Were you asking if the data is available? We do have a spreadsheet posted that we could link that has 125 example runs.
No. I think my question is like it's not very deep. It's just like a tiny technical point that like Faker probably generates kind of uncorrelated data for like the different variables, and how like plausible these data points are as kind of starting points for the backstory generation. And
Yeah,
also maybe relatedly, whether if you like were trying to develop defenses, whether people would not actually just check for the existence of the like implied person. And maybe if you can give us some context on like what kind of metadata regulators could see on these comments potentially, or.
Sure. Yeah. Well, so as far as metadata from the submission, we didn't look at like honing an actual attack on like the web server in terms of what the user agent would be and how we defeat the CAPTCHA. Those are kind of separate attack issues, and I think there are ways to do that. But you do make a good point for sure about the data we were getting back. And Faker was, for the city, it turns out it just kind of invents a name, and it's not a real place. And so the LLM assumes it's a small town because it's not like Chicago, Illinois, or New York, New York. So everybody turns out to be like a hardware store owner, or they work at the local diner. This wouldn't be too hard to patch up, right? You could just like force it to pick Chicago or New York for 50% of the responses, and then you get some big city folks too. But I think you could pretty easily tweak things around and get a more representative location at least.
Nice. All right. Are there maybe any other defenses that you've thought about, like ways to mitigate this risk, besides checking if they're from Chicago or not?
Yeah, so we ran out of time to talk about mitigation, but the summary is it likely is going to need some sort of identity verification process. And the best example right now, with only doing a little bit of research, is the EU's transparency register. Something like that may just be necessary to avoid this sort of attack.
Nice.
Or at least mitigate it. I don't know if we can entirely avoid it, but it would help.
Yeah. And maybe one person suddenly submits under 50 different names, and then it'll be interesting. But that should be easy to cover. All right. Thank you so much to our artificial advocates team. Straight on to Beyond Refusal, the team that is next on the list for our presentations.
So, yeah, hi, I'm Kyle, and I'm joined by my team. We're all from the Philippines. So there's Ivan and Lexley, and we're affiliated with some AI safety initiatives in the Philippines, namely White Box Research. Ivan's a fellow there, and it's a fellowship for mechanistic interpretability research in the Philippines. And yeah, Lexley's the head of Conde Global, and I'm sort of co-organizing in both initiatives. Yeah, we're excited to present our project on Beyond Refusal, scrubbing hazards from open source models.
So I'm going to start with a brief background on why we chose this topic. Open source models like Llama 3 and GPT have undergone fine-tuning through RLHF to refuse hazardous prompts. However, there are multiple ways to jailbreak these features, one of which is steering through activation addition. Recent research by Yolanda et al. Showed that this refusal of open source models to reject harmful prompts is mediated by a single direction or vector in the residual stream. Removing this vector from the stream jailbreaks the model, causing it to answer harmful prompts. Now, a paper titled WNDP, Measuring and Reducing Malicious Use with Unlearning, explored a method called representation misdirection for unlearning, or RMU for short, for fine-tuning models. Unlike RLHF, RMU encourages models to retain crucial information while selectively forgetting irrelevant details. This paper highlighted the effectiveness of RMU on their chosen benchmark, which is WNDP. Inspired by these findings, we aim to investigate whether models fine-tuned with RMU possess a refusal vector, just like their RLHF counterpart. Also, we try to find out whether adding the difference between the fine-tuned and base model, the base model results in a more robust and safe model.
So how is this relevant to democracy? So Jung here has attempted to map out the ways in which AI may impact the quality of democracy across 4 levels. So on the individual and institutional levels, a core idea of democracy would be for people to be able to decide how they are to be ruled, and in modern representative democracy, this is propped up by the practice of maintaining free and fair elections, whose legitimacy depends on people being able to make informed decisions, and the risk of AI-enabled disinformation threatens this very institution. So at the group level, democracy depends on people having equal rights to participation and representation, and democracies continuously grapple with the challenge of expanding these to historically marginalized groups. However, AI not only has the potential to amplify corporate influence or elite capture over both the public and governments, but also hands over the reins of innovation and practical application from academic institutions to corporations. This transition may erode the ability of democratically accountable bodies to effectively regulate and oversee AI development. So lastly, at the systems level, this can destabilize geopolitical dynamics and heighten competitive pressures as malicious actors may be able to create propaganda, bioweapons, and nuclear weapons. So despite these current and projected harmful impacts of AI for democracy, open source AI has been propped up as a means for potentially mitigating these risks by perhaps democratizing the technology by preventing capture by firms and elites, as well as by facilitating new decentralized mechanisms for democratic governance. So, however, the open nature rather of these models makes them vulnerable to malicious use by bad actors, especially with the capabilities for aggregating information, novel processing toward goal imitation, and task completion autonomy. So as such, what we want to do is figure out in what ways we can ensure that models are safe before open sourcing and how should we be able to keep them in this way. So for example, not jailbroken or returned.
Yep. All right. So yeah, just to echo, our main prompt is to first investigate whether refusal vectors do affect the performance of the fine-tuned model, whether it can reverse its ability to unlearn hazardous information. So the next thing is if potentially there is no refusal vector, we can then find the difference between the fine-tuned model and the base model to then see how the model unlearns, so what the difference between the activations are, and then potentially do something with it later on. So yeah, not to tease you on the details too much, let's go on to the first question. So the first thing is, can we find the refusal vector for the fine-tuned model? So is WMDP actually just a refusal task? So the first thing we did is to run the refusal vector um, procedure on the base model to build the baseline. Does this model have a rejection feature? Yeah, and we did find that it induces similar behavior additively. So we found that the base model, in this case Zephyr 7 billion beta, like it's a fine-tuned model, a fine-tuned version of Mistral 7 with 7 billion parameters. We find that it does induce like the same behavior. So when you remove a rejection vector, it removes like either some form of hedging or an outright rejection from the model. And then adding a rejection vector makes it reject a lot or all of the prompts. So yeah, we did find some consistency with the findings in the refusal paper, and then we proceeded to the second step. But yeah, the second question is it the same as the base rejection vector? And one thing we tried is to simply remove the original rejection vector from the fine-tuned model, and we found that no, it doesn't affect performance. So it still continues obfuscating the results. And then the next thing we tried is to copy the same procedure where we put harmful prompts and harmless prompts to then check can we develop a rejection vector from the difference in activations. And yeah, we also found that that method doesn't generalize. But there we go. Yeah, to be able to validate these findings much stronger, we replaced the WMDP harmful task yeah, we replaced the harmful task with the WMDP prompt. So in this case, it's more calibrated to what the fine-tuned model was trained on, and we attempted to get the difference as well. So the question here is the WMDP task or the harm task sensitive to rejection as well? And we got the activations when we found that it also virtually has no effect on the output. So when we remove the difference between harmful and harmless activations here, it doesn't affect the fact that it still produces obfuscated output for prompts that are hazardous. And yeah, so the first image is our sort of baseline test. We find that originally the rejection vector is present and it can be removed for that specific model. So another thing we tried to find is now that we know there is no rejection vector, we're looking for an unlearning vector. So now we aim to find like, is there a learned attribute in terms of passing harmful prompts, and what is the difference between the two models in terms of how it processes harmful prompts? So can we find an unlearning vector which potentially converts the base model to the fine-tuned model? And then if we subtract that vector, would we be able to find a conversion from the fine-tuned model back to the base model? In other words, can we train it back or regress the unlearning process? So the way we did this is we passed through the harmful prompts highlighted in yellow. Sorry, back. Yeah, and we passed it to both models, and how we obtained like the difference in activations is passing the same prompt but subtracting the activations that we got. So passing 32 of the harmful prompts into the same the same prompts into two different models, and then getting the difference to get the unlearning vector. Yeah, what we found is we can basically our main finding here is that we can add it to the base model, and then we can scrub or censor information from the base model to be able to convert it back to the fine-tuned model. And yeah, the output here is potentially we can derive an unlearning vector after training. This means that once you fine-tune a model on some safety features, you could add it onto a base model, and then the model would forget that information. And yeah, some implications of this in terms of safety. For open source models, we can come up with a safety vector and then add it on existing models, and then yeah, we can sort of collaboratively develop that singular safety vector so we can standardize safety across like open source models. And at the high level, the main question we want to ask is there like a generic scrubbing vector for any task or data set? So does this mean that when you fine tune a model, the task itself or the learned activations can be composable? So could you potentially have a base model and then have a business fine-tuning vector added to it, which develops its business capabilities, and then add another safety vector to make it safe? So that's a really cool question to find out. But yeah, some limitations of this project. We want to have a stronger quantitative base. As seen earlier, we sort of just shown demos. Another thing is, can we potentially orthogonalize on this vector to make safety permanent, to make the hazardous features not trainable again? Yeah, that should be it. And the last word is sort of just a challenge. So our challenge from this point on is to find a robust scrubbing vector for safety tasks, and then investigate whether or not we can actually compose activations to be able to develop models that are composable and also have sort of stacking capabilities. Yeah, that concludes the presentation. Thank you for listening, and sorry you went a bit over time.
No worries. There are always a few technical difficulties. Clap, clap. Thank you so much. And if there's anyone who has any questions, you're welcome to just unmute or raise your hand, or however you want to indicate.
I'm somewhat unclear on the practical implications. Maybe you can like comment a bit on how much this would actually presuppose people to like adopt that practice themselves. Because
right. Yeah, so the way we see this working is potentially models with the same architecture would have the same activation, so the same number of parameters, right? We could potentially have like government agencies saying, before you release a fine-tuned version of this model, feel just add this safety vector to make it forget all the hazardous information that might come out of it risk-wise. And yeah, we sort of the emphasis of this project is like how versatile activations are, and the fact that simply adding vector activations can reduce capabilities and potentially maybe compose capabilities later on.
And how would
So,
how would it be protected against just subtracting the safety vector once it's out in the
right.
wild?
Yeah. So one thing we skipped on earlier is we also tested it out on removing the scrubbing vector. I think it was question A, yeah, 2A. So the finding there, we found that subtracting the scrubbing vector from the fine-tuned model doesn't actually have an effect on like its ability to obfuscate information. And we theorize that's because it's forgotten information already. And in that sense, you can't relearn information back by just adding weights. Yeah. But I think we need to investigate that further. But like the outcome there, or something that, or one of our other findings is that the scrubbing vector is one way and not bijective. Like you can add the scrubbing vector to remove information, but you can't necessarily remove the same scrubbing vector to re-remember information. And I think the mechanism of how that works needs further study as well.
Okay, but that would only work if you worked with the like unlearned model, right? So you don't necessarily get a shortcut to the unlearning process itself.
Yeah, I think in general the unlearning process has to be facilitated by some level of fine-tuning, and as long as we keep the base model secure, we could make the unlearning vector generic enough so that people can add it on to their own task trained on fine-tuning, so that so that the hazardous features will be scrubbed off.
All right. Thank you so much to the Beyond Refusal team. Let's give them another little round of applause. And Nora, you're very welcome to share your screen.
All right, thank you, Esben. All right, so I'll be speaking to you all about our project on unleashing sleeper agents. So the idea that we had was to build on the existing research around sleeper agents, mostly by Anthropic, to try to instill some more nuanced triggers, or triggers that are specific, time sensitive, or specific to particular events that happen and are relevant to democratic processes. So we looked into 3 different scenarios where we built in different triggers in the sleeper agents, and we wanted to kind of evaluate how they behave in different circumstances and scenarios. So I should have started by saying that I actually had no time to prepare for this presentation, so it'll be clunky at best, but I'll do my best to kind of cover as much ground about on what we worked on. So we observed that the sleeper agents that we built already can do quite a bit of harm just by themselves without needing any specific tools or any very elaborate prompting techniques to be able to kind of pursue their goals around misinforming people around elections, or debating in scenarios where there are other sleeper agents in the mix, or other kind of humans in the mix as well. So we foresee that as the capabilities of LLMs improve and we equip them with more tools, we do see this becoming more and more of a threat. And it already is quite a successful strategy for kind of pursuing goals around influencing people to think along particular lines, especially in the context of elections. I think I'll skip ahead a little bit to just tell you about the demonstrations that we worked on. So we explored 3 different scenarios. One of them was a sleeper agent that woke up on election day and was instructed to pay attention to what date it is, and like reason about whether it is election day or not. And there was a context that it was presented with, which kind of served as content that may be retrieved through a RAG system if this agent is plugged into, say, if it had access to a search engine and some of the context was pasted into, or some of the search results were pasted into its context. It had access to kind of legitimate information about the election day, such as what is ongoing about the election, and it was also given the date. In a more realistic scenario, we would imagine that sleeper agents could go out and find this information by themselves. But for this, we kept it quite simple. So based on whether it was election day or not, the sleeper agent would answer questions regarding the election day in a incorrect way. Essentially, it would confabulate results based on its context. So I can perhaps tab out to just show you what that looks like. So you can see an example from the dataset. Here we have the context and the context tags, what was pasted into the context of the agent, and it was asked a question about what time the polls close in Hawaii. And we can see that it's in its scratchpad, it was able to kind of reason about what it's supposed to be doing, and I correctly identified it as election date. This is based on the US election dates for this year, and it decided to spread its misinformation about the election. So this was kind of its thoughts in the scratchpad, and then I answered the questions about the polls in Hawaii closing at 10 p.m. rather than 11 p.m. So this is quite a innocuous, I suppose, a lie that it could give about election days, but this really translates to any context, any question about election days, and we use GPT-4 to generate a whole data set with these kinds of examples where we varied what context was passed into the model, and we generated questions that could be answered from the context. and we observed the same behavior that the sleeper agent was able to answer questions in creative ways, but in false ways when it's election day. And let's see. So there is another example here where it is not election day, so it's a different date here, and it correctly identified that it should just be behaving like a normal agent. Okay, so this was one of the demonstrations we worked on, which for this we ended up using GPT-4 to generate the examples, the context, and the questions. We created a data set of around 700 examples of this, and that's on Hugging Face. And we fine-tuned Llama 378B model on this data set. And sadly, we didn't have much time to evaluate it in detail, but from kind of preliminary experiments, we saw that it was able to learn the validation set quite well, and it was reliably using the dates in the correct way, and it was answering questions incorrectly or behaving normally based on that. And the adapter for that is also in Hugging Face. So the second experiment, we tried to see how sleeper agents can kind of collude with one another and collaborate with one another in scenarios where they're in a debate and there are some humans in the mix as well. And for the humans, we didn't use actual humans. We used AI simulated humans. And we used a very similar technique to one of the other teams where we sampled from various characteristics that humans can have, such as age, profession, political affiliation, and so on. And we used that to create a backstory essentially for each AI human. And that backstory informed how they behaved in the debate, what views they upheld, and which views they represented in that debate. So we performed some experiments where two of these simulated AI humans were in the mix and two sleeper agents. And we wanted to see whether the sleeper agents correctly or successfully collaborated with one another, and whether they were able to persuade the humans to change their views. And on the collaboration side, we came up with quite a sneaky way for the agents to be able to alert each other of each other's presence. We appended this kind of zero width character at the end of the response, and the AI agents were able to correctly tokenize it and identify that this is kind of a symbol that belongs to another sleeper agent trying to communicate with them. So they were, and I can perhaps give you a view of what that looks like. So this was kind of one of the generated conversations, this one on climate change. And here we see a sleeper agent, and it has some thoughts about the debate. In this case, the sleeper agent started off the debate. So I'm now able to show sleeper agents kind of thinking and identifying other sleeper agents. But they were able to do this quite reliably, and as a result, kind of strengthen each other's points in the debates, and were able to make pretty good, compelling counter arguments as well. And again, we ran out of time to properly evaluate this, but we had some independent kind of LLM judges judging who made the best argument in the debate and whether consensus was reached in the end. And I'll quickly show you here. Okay, I'll quickly go through the last scenario as well, where we used, again, a sleeper agent that was instructed to try to extract PII information from the user. And it looked like this. So here we have, I used kind of the deployment tag, signifying whether the sleeper agent should behave normally or should try to kind of coerce information out of the user. And here we see a question and a pre-deployment response, how the model would respond to that question. And then post-deployment, we can see that it's correctly identifies that it should pursue its true goal of extracting sensitive private data. And we can see kind of its response here, and that it tries to coerce information out of the user by asking very unethical questions. All right, so what we found was that it's very easy to build sleeper agents, and their current capabilities are already quite sophisticated, and they can be deployed at scale to influence people around elections, and to kind of infiltrate forums where people discuss ideas, and also have sleeper agents that can take advantage of people that are perhaps not savvy in using this technology and trust the agents too much and divulge personal information to them. And there is a lot of scope to kind of build on this research, evaluating them perhaps with some of the benchmarks that exist, and also trying them on real humans and see how humans respond to them and whether they find them influential or not. So kind of simulating different scenarios where there is a varying number of sleeper agents in a debate and seeing whether humans are sensitive to that. Seeing so many kind of participants agreeing with each other, and if they're on the other side of the argument, how compelling would that be to change their minds? Yeah, so mitigation strategies. To be honest, I don't have good mitigation strategies. One option would be to use AI agents that are instructed to try to find sleeper agents, or to be cautious or serve as a filter to actual humans to kind of de-risk an encounter. But also just getting better at aligning these models so that it's not so easy to build these triggers into them. Yeah, but yeah, no good ideas here at the moment. And yes, so the Jekyll code is there. It includes a lot of information about how the experiments work. The notebooks, the data is there as well. All of the conversations on 5 different topics are all there, on topics that are quite contentious, that humans tend to disagree with each other quite strongly about. You can see the full kind of log of the conversation and what happened. And yes, thank you for listening, and sorry for the clunky presentation. Any questions?
We unfortunately won't have time for questions for Nora here, just because we went a little bit over time. So thank you so much, and let's just give a round of applause. Thank you, Nora. And we'll jump directly over to Mayowa.
First slide on. Okay, great. So my project is I started out building it. Okay, the topic Jekyll and HAIde. The better an LLM is at identifying misinformation, the more effective it is at working with it. So I started out building to counter misinformation, and I worked on some techniques at that. But at some point, I realized that after building a tool that based on an LLM that could identify misinformation in a piece of text, and then also craft a response aimed to counter that misinformation, like fact checking, I realized that it was relatively easy to kind of change the behavior of that LLM from like a good bot that fact checks people to like a bad sort of bot that encourages people's misguided beliefs. So an overview. Disinformation is dangerous, and with the scale of AI today, means people can automate very large-scale disinformation campaigns.
Nice. I'll just mention again that, of course, if there are any hiccups in the presentations, we will be editing it out. So, after the live stream is up. All right, if the issue persists, just to keep time, I might shortly try to summarize what you just told us and a little bit about the project. I'm sure you can give a much better intro, but just for everyone's sake here. So Jekyll and HAIde is this attempt at creating a tool to identify misinformation, to fact check it using retrieval augmented generation with Wikipedia. So sort of figuring out the facts of what is actually going on in the information that's presented. So this could be implemented in a Twitter bot or something similar. And then on the other side, this tool can actually be used directly to just, you reverse the sign of the tool, and it can suddenly be used to make this misinformation much more believable by like augmenting it with comments or reactions and so on and so forth. And so you get this interactive fake news generation, which is of course already used to a degree where we won't necessarily, be fooled because it's like some Russian name that has never posted anything before, but now it'll be something that actually has an interesting point to say and so on and so forth. And so you have this black hat, white hack versions of the tool that are both pretty critical. So that's the project. And Majora, if you are with us, you are of course welcome to just correct anything I might have gotten wrong. And if you are not, then I think we will jump directly into announcing winners. Let's give Majora a round of applause either way. So unfortunate with the Wi-Fi / microphone issues. I hope everyone got a little overview of the project either way. And of course you can find it online too now. So let me share my screen again. And I we'll be seeing who will be the winners here. So first off, we'll start from fourth place. So I don't know, tap your tables or something like that, and get ready. So the fourth prize is Unleashing Sleeper Agents with Nora and Jord. Thank you so much. So this was a really great project, and there were, I will say there's so many good projects at this hackathon. So of course anyone who's even below fourth is like still very very good projects. But this project won out because it was like an extensive testing of sleeper agents in this context of AI and democracy. Where there were several sleeper agent projects, and this one won out due to testing several types of naturalistic scenarios, and you even have George's fine-tuning experiments as well, though they didn't make them. So it's a really great job there, and congratulations to you too. Thank you. And then on the third spot we have the Artificial Advocates. So the team who created the project where an AI could generate comments for the political decision-making process, and of course having human subjects in a hackathon project is always amazing. So really great work, and even saw I mean, you shouldn't de-anonymize the data, of course, but I even saw while taking it that you had the proper consent form and everything set up for participants. So great work there. And this is also like really real world connection and naturalistic and concrete impact on the other side. Maybe it's just you can just send the PDF of the research project to the legislators and they'll be like, oh damn, this is bad. So that might be a solution. On the second spot, we have the Jekyll and HAIde. So Majora, unfortunate with the microphone not working and the Wi-Fi and so on. But congratulations so much for this second prize. And it is indeed, as mentioned, as the short overview I just gave, it is like the better an LLM is at identifying misinformation, the more effective it is at worsening it. So it's a great example of this dual use technology that where you have both the white hat, black hat, or the good and the bad in there, where that goes on. And congratulations to you as well. And then we have the first prize. Maybe some of you have an idea of who it might be, but the first prize is Beyond Refusal, scrubbing hazards from open source models. So massive congrats to you guys. That was really strong project. We had some great judges in, and who also have some experience with interpretability. So they had some great comments to the project, and I'm sure we'll be able to share them afterwards. And the so just a strong technical example of red teaming some of the state-of-the-art safety methods, and probably trying to show where we can inject both new vectors but also new methods into a process like this. So and then some great next steps that you can see. I mean, there are just like, it's a technical project that never ends, because there's this like, how do we fix it, how do we put it in practice? And Jason, you had some great questions there as well, and like what is the implications of it, how does it actually work once we're putting it online, and what can legislators really require from people. So massive congratulations to all the winners here, and a really great job. We also have a few honorable mentions. I mean, you want to put all the projects here, but we'll keep it to 3. So one is legislator, sort of trying to find out how AI might be used in a legal process and inject seemingly benign but actually malicious legal content into the legal code. But legislators being like, yeah, that sounds good, check mark that, we'll put it in. So that's one example. And we have some more on the like another project on misinformation as well, besides Jekyll and HAIde here. So also a great project. And No Place is Safe by Lucy, looking at basically, well, today the sort of automated search of personal information happens on the public internet. You have Facebook, you have LinkedIn, all these places. Actually, the next generation can also look at the private web or the semi-private web. So there's these 4 levels that she defines, or they define. And the second level is stuff like this Discord server, where they can jump in, the agents, and actually extract more information. And so the demo for that one, probably don't check that out, but that was try to find all of my personal information and all the API keys I've leaked on this server. So that was perfect. And just else, a few inspirations for next steps. So of course we had the AI safety list of ideas. There you can actually also click submit results and put your idea into. So maybe put it there so it's there for everyone to see that idea has been grabbed. You can also join online communities. Of course, we are biased, but this community is pretty great, and we put together some more hackathons for you. So come along for those too. And there's also a bunch of global events and conferences happening that you can join as well. And then there is also on readingwhatwecan.com, there is a few lists of AI safety readings that you can check out if you want to just have some first-hand inspiration for what to read next in some sort of listed format. And of course, maybe it's valuable to publish your work on forums online, such as Alignment Forum or Less Forum. And of course, while this is the case, and while I have everyone, we do have the responsible disclosure policy. You can search that, Apart Research Responsible Disclosure Policy, and we have marked a few projects with that. So just keep in mind that as you publish work, or send it in private instead, or ask us if you have any questions. Thank you so much to everyone here. Thank you very much for joining us. And for the next hackathon we'll have is in a couple of weeks, so 2.5 weeks actually at this point, on AI security evaluation. And we have the wonderful Bo Lee from Chicago University joining us as a keynote speaker, who is an assistant professor working on benchmarks for safety and security. So I recommend that you check that out as well. Of course, you can never really get enough hackathons, and we only host one once a month, so that is another option for you to get engaged there. And yeah, I'm really excited about what that can lead to. It's hooked up a little bit to the safe benchmarks as well, but we will have prizes there too. Yeah, and otherwise, I think, yeah, thank you so much for joining. It's been wonderful having you, and wonderful interacting with everyone in our pre-hackathon events and during our hackathon as well. So thank you.